Hey everyone, and welcome back to this class, the Numpy stack in Python. In this lecture, we are going to look at another popular visualization called the scatterplot. In the previous lecture, we looked at an exact function. What we tried to do in machine learning is we have a bunch of data, but we don't know the exact function that it came from. There could also be noise added to that underlying function. So what we're really trying to do in machine learning is function approximation. In this lecture, we are going to go back to the linear regression class folder and look at some of the data there. I happen to already be in this folder, so I'm just going to continue. So I don't have pandas yet, so I'm going to import pandas. And I'm going to read the data from data1d.csv. There is no header, and I'm going to turn this into a matrix. So the x-axis is the first column and the y-axis is the second column. So I'm going to assign those. So the colon here just means select everything in that dimension. So since the first dimension represents the row, where each row is a sample, this means select all the samples, but only one of the columns. Now we're ready to do a scatterplot. So we do plt.scatter, pass in x and y, and we can show it. Okay, so it's almost a line. Note that there are other useful arguments into the scatter function that we could use, but I'll only bring them up as needed. And right now we don't need them. This kind of stuff is not worth committing to memory, so just look it up when you need to. Recall that when doing a plot, nothing shows up until we call show, which means we can keep adding stuff before that. Now I happen to know what the correct line is that fits to this scatterplot data, so let's plot them both at the same time to show you that it actually fits. So, do we have NumPy? We have NumPy. So let's create some x points. The data goes from 0 to 100, and this is 2 times x plus 1. So let's do the scatterplot again, and let's plot the line. So that was what we studied in the previous lecture. And now let's show these together. And we can see that indeed the line is a good fit.